see on page 3, 6.0, getting ready, and there's just 3 things that we're reviewing. It's linear relations, line of best fit, and slope. Okay? So you should already have a good understanding of those 3 things. You just took a test on it. And this unit, I like this unit, but it's more of lines and linear relations, and you find out what happens when lines cross each other and where they cross each other, and parallel and perpendicular and all those kinds of things, dealing with slope and y-intercepts and different equations for lines, like writing the same line using different equations. So it gets a bit challenging as we go along. You have to have these basics. Another thing of basics that you need to understand is coordinates on a plane. You need to understand x and y coordinates and how to plot points on a grid and all of that. Okay? So here we go. Linear relations. 2 variables share a linear relationship if the graph of their data, 2 variables share a linear relationship if the graph of their data forms a straight line. Okay? You have a little graph there. You can draw any straight line.
We went perfectly straight up.
That's possible.
I like mine to be
Okay. Just go ahead and do something similar. Just do something similar to what I've drawn. All that you need to understand about a linear relationship and linear relations is that if you take the independent variable and the dependent variable and they are related to each other in a way that is linear, the graph that they form will be a straight line. So you could take any of the points on here and you could calculate the slope, and the slope between any of the points will always get the exact same answer. It's a constant of variation. It's a straight line. Okay? So whether let's say you're running at a constant rate, whether you are talking about the 8th kilometer or the 10th kilometer or the 2nd kilometer that you've run, your graph will always be going at the constant rate. It'll be a straight line. Okay? The second thing that we're talking about is line of best fit. Line of best fit. And you should be a bit familiar with that. Sometimes a relationship is not perfectly linear. Sometimes a relationship is not perfectly linear. When this happens, we can draw a line of best fit. This line passes as close as possible to as many points as possible. Okay, so you have a little graph there. Again, I'm just doing a quick sketch. Looks something like that. Go ahead and plot some points that are close to linear but not quite linear.
They have to be on equal sides.
Okay? Yeah.
Equal
Ish.
amount.
We're not getting too specific. It just has to represent the data well.
Are we
So the line of best fit is the line that will pass as close as possible to as many points as possible.
Does it have to be on a straight line or can it curve?
It's a line of best fit. Straight line.
So it cannot curve.
Correct. There is such thing as a curve of best fit, but we're not there yet. We're working on lines and linear relations. So ours are always going to be straight line, constant slope. Okay? You can make a little note for yourself that this blue guy, this is the line of best fit. You could also have an outlier. Thanks. That's good. Alright, everyone has this? Did I clear this? The last thing that we're talking about is slope. And you should be fairly familiar with what slope is. We've taken notes on it several times and we're going to do several more. So here we go. The slope of a line illustrates the rate of change. The slope of a line illustrates the rate of change of one variable with respect to the other. Okay? Slope is represented by what letter? By M. And M equals rise over run. Another way to say that, M equals
Y2 minus Y1.
No.
Height?
No.
No.
okay. No, that's good. Yeah, I'm going to use this one first. Delta Y over delta X. And then here we can also write your equation that you actually use when you have two coordinates. Y2 minus Y1 over X2 minus X1. And that's exactly what delta Y means. It means the change in Y over the change in X, which is simply the difference between your two Y coordinates over the difference between your two X coordinates, as long as you're consistent between which point you're using as point 1 and which point you're using as point 2. Okay, you have a little chart there. We've drawn this exact picture before. Go ahead and put a point somewhere over here. Put a point somewhere over here. Okay? Call this point x1, y1. And these coordinates are x2, y2. Please use a straight edge to draw your line. Okay, we now have a line segment. And what am I going to draw in order to represent its rise and run?
Dotted right angle.
A dotted right angle triangle. Okay? On this vertical length, that's the change in y, so that's our rise. The horizontal length represents our change in x, that's our run. Okay, so always keeping in mind, just watch for a second. I'm going to add a few more details to this chart. There's your two axes from 0, and I'm just looking at the positives here, but if I trace this point down to here, this would be the value of x1. And if I trace this point down to here, this would be the value of x2. So the space in between is x2 minus x1. There it is.
Okay,
That's
got
your
that
run.
wrong.
If I trace this point across, okay, I've got the value of y1. And if I trace this point all the way across, I've got the value of y2.
So in between, like the amount of numbers in between should be
y2 minus y1 is the same as the rise. Okay?
That makes sense.
You have enough time right now to probably do the 6.0 practice pages. In the following notebook, most of your practice problems are right in the booklet for you. Some of them are in the textbook, but a lot of them are just in the booklet. Okay? But you still need to complete them in a separate notebook, nice and neat. Okay? That will be checked regularly. So go ahead and start on that.
I